Hello friends, today we will learn how to use curve fit in Python. So in my previous video I have shown that how to use polyfit to fit the curve, fit some data with some polynomial curve. So today we will learn something more general, which is curve fit. So to do this, let me first create some data. So using Python, maybe I am using this vim data.py. So I can just explain in short that in my previous video I have shown that I have explained all the lines. So here this is the NumPy library import. Then I made a linear space named x, which is -6 to +6 with 100 points, and then the y is equals to exponential of -x², that is a Gaussian. Then I opened the file out.txt in write mode. Then I have written this with the first column is the x data and the second column is with the y data. So if I run it, so save it and run it, then it will generate out.txt file, which you can see that this is so set number will show the line number. So you can see that here this is line number. So you can see that this is -6 to +6, this with 100 points. So this is the x values and this is the y values. Okay, so now what now what we do that let us just write a file curvefit.py, and first import numpy as np, import scipy dot optimize sorry, so it must be, and it should be this form scipy optimize import curve fit. So this is curve fit function, so we have imported from scipy optimize. Now let us just load the out.txt file. So for that if is equals to np.loadtxt function will load the file in some array. So the array will be stored in f. So now this if you can just print it out. So you can see that if I just print this f, it is a second two-dimensional array in which the first column is the x array and the second column is the y. So now let us just take the first column. So first column is all the rows, the first index is the row index and the second index is the column index. So this you can see that so first column means 0th index in the column index. So you can see that this is -6 to +6, this is the x. So we can just store it in some variable array x, and let us store y from f1. Okay, so these are my data. So now to do the curve fitting, so as we know that this is just a Gaussian function, so let us just we can fit with a Gaussian function even. So g x comma a comma b, a and b are the parameters. So a comma b. Now so g is basically return some a multiplied by np dot exponential of minus b x square. Yeah. So now if we just fit, then for fitting this will return some parameters and error. So this para and error is equals to curve fit first argument should be the function, and second argument is the x, third argument is the y. So now you have parameters, so just print the parameter. Let's see. So it should print the parameter, fitted parameters. Okay, so a is 1 and b is again almost 1, so it is fitting well. So to do something more and to do the verification, you can just visual verification. You can import matplotlib to plot, and then just your z is the fitted curve, so fitted curve will be g of x comma para 0, so a must be the para 0 and b is the para 1, and then just plt dot plot x comma y with some just maybe point with point, so scatter, it will make some scatter plot, and x comma z with the continuous line. Okay, and finally you can just show these plots, so you can just run this code. So it is this is because of my device, it is really working slow, but anyway, so we can see that this fitted curve is working very well, but this is because of our data was Gaussian and I am using Gaussian. Okay, so but we can do something more, we can do with something different function maybe. So maybe we can just use some Lorentzian function, and that can be like this. Return a divided by x square plus b. Okay, just I am commenting this line, though it is not required, but for transparency I am just commenting the second line, and the first line is basically a Lorentzian function. Now you can just check it out. Yeah, so this is fitting well here, but it's not the tail. Okay, so this is how it works. Okay, so that's how the curve fitting works. Okay, so thank you, and please subscribe and share.